Hi, good day once again. So I am the next reporter and I will be discussing to you the intertwined topic which is reliability. So earlier in the from the previous reporter, he talked about validity. So this time we are going to talk about or tackle or discuss reliability. So what is reliability first? So reliability, it talks about reproducibility and consistency in methods and criteria. So, reliability is mostly applicable in assessment. So, in assessment, it is said to be reliable if it produces the same results if given to an examinee on two occasions. So, if an assessment could be reliable if it has the same results. So, it is important also to stress out that reliability pertains to the obtained assessment results and not to the test or any other instruments. So, another point is that reliability is unlikely to turn out 100% because no two tests will consistently produce identical results. So it may have disagreements with the definition itself that an assessment is said to be reliable if it produces the same results. So in a reliability measurement, we cannot ensure that 100% we can have the same results because as a matter of fact no two tests will consistently produce identical results, right? So wala dyan mga sometimes there are tests that are retest again, so sometimes it may not have the same results, of course, like lahi man ang atong pagsabot within that day. So that is may come from some factors such as environmental factors. Of course, we have the lighting and the noise, the physical well-being, and of course the student error. So as a student, we tend to commit error, we tend to commit mistakes sometimes. So that is why another point in a reliability measurement, it is unlikely to turn out 100% sure. So reliability is expressed as a correlation coefficient. So what do you mean by that? So from the word correlation, the relationship between the two, or what is its similarities. So what is its significance? The correlation between the two variables. So that what is meant by correlation coefficient. So in the reliability measurement, we tend to measure the correlation coefficient. There are two types of reliability. So we have the internal and external. So internal reliability, it assesses the consistency across items within a test. While the external, it gauges the extent to which a measure varies from one use to another. So those are the types of reliability. We have the internal and external, which assesses the consistency within across items within a test, while the external, it gauges the extent of a measurement from one use to another. So we have the sources also of reliability evidence. First, or letter A, we have stability. So an agreement of measuring instruments over time. So in stability, we have this what we so called the test retest reliability. So it measures consistency. So test retest reliability, it correlates scores obtained from two administrations of the same test over a period of time. So from the word itself, test retest, it occurs from two administrations of test. We have the test A, such as in that period, and of course the test B on the other period of time also. So to determine stability, or a measure or test is repeated on the same subjects at a future date. So results are compared and correlated with the initial test to give a measure of stability. So in a test retest reliability, so we tend to measure two administrations of test. So to determine its stability. So a measure or a test is repeated on the same subjects at a future date. So di bali, in a test retest reliability, for example, this day we conducted a test. Next 3 months from now, we are going to conduct again another test, same with the test that has been conducted this day. So that would be the process of the test retest reliability. So let's say for an example, So 10 students from grade 9 Rizal who were chosen to the reliability of an achievement test in science. So using the retest method of Spearman's row, find the reliability coefficient. So this time we are going to find the reliability coefficient of such test in an achievement test of science. So we have this following scores. So from X, we have this X. This shall serve as the first take of the test. So we have the following test scores. We have the 25, 28, 20, 19, 25, 23, 19, 20, 16, and 24. So in the next day, or in the next retest, we have this following scores also. We have the 26, 29, 26, 22, 20, 29, 20, 27, 24, and 25. So those are the following scores. So this time, we are going to measure its reliability or reliability coefficient. Alright, try to observe the table above. So we have here our number of students. To count off, we have 10 number of students. So as you can see, there is also a variable of x and y. So x, it is a representation of the test scores of the first take of the students, while y shall serve as the retest scores of the following 10 students. So as you can see, in the next column there is a rank. So in order to find out for the rank, so we have here the dx and dy variables. So in dx, it is the rank based on the first take of the scores of the students. dy shall serve as the rank based on the retest scores of the students. So let's begin with the dx. So student 1 in the first take have the score of 28. So as first take, so we should rank him 1. In the next, we have student 2 have the test scores of 25. Same with the student 3 of the test scores of 25. So in that case, so to find for the rank of the following students, so student 2 and student 3, you are just going to add them, so which is 2 plus 3, then find the average, so divided by 2, and that shall serve the rank of the following students. So student 2 ranked 2.5. So based on the average that we've got from the, of course, from the solution. So 2 plus 3 divided by 2, and that shall serve the rank for the following students who have this same test scores. So same with the number 4. Same with the number 6 and number 7. So they have this following test scores of 20. So just add 6 plus 7 divided by 2, and that shall serve the rank, which is 6.5. So, and also with the number 8 and number 9, we have here the same result, 19. So which we're just going to add them, of course, 8 plus 9 divided by 2, and that shall serve the rank, which is 8.5. So for those scores that have no the same results or the same test scores, so just rank them based on their number. Next, we are going to rank the retest scores. So as we can observe, in the student 1 and student 2 have the same result, which is 29. So of course, just same process, just add 1 plus 2 divided by 2, and that shall serve the rank, which is 1.5. Same with the number 4 and the number 5, and so on. So just follow the scale, which is the ranking scale. We have from 1 to 10. So just add that. So next, we have the difference, the D1 and D2. So this time, just subtract the difference from the first take and the retest take on the ranks. So of the ranks, rather. So here in the first take, our first student rank 1, and the second test scores, our first student rank 1.5. So just subtract 1 minus 1.5. We have here negative 0.5 or 0.5. Of course, 2.5 minus 1.5, of course, 1. 2.5 minus 3. So we have here negative 0.5. So same process, and so on. We have here just subtract the following ranks of the students from the first take, from dx rather, and from dy, which is the first take and the retest take, and the retest scores based on the ranks. Next solution is, we have here the d squared. So just squared the result come from the subtracted ranks. So squared of 0.5 is 0.25, right? And of course the square root of the square of 1, of course 1, as well, and so on. So just follow the pattern of how we subtract and of course squared those following scores. So in total, we have here, just add the following squared scores of the student, yes, just add the following difference test scores. We have here from 0.5 plus 1 plus 0.25 rather. So 0.25 plus 1 plus 0.25 plus 0.25 and so on. So which has a total of 4.00. So next, we have here the formula of finding the retest reliability. So R is equal to 1 minus 6 summation of D squared over N to the power of 3 minus N. So just follow the formula. So we have here R is equal to 1 minus 6. Next, the summation, the total summation of the following D squared, we have here 4. So, di ba? 4 man itong nasa solution ganiha. 4 in total. So, 4.00 rather. So, we have here 4. Over the number of students, we have 10 to the power of 3 minus 10, which is also the number of students. So, same process. So R is equal to 1 minus 6 times 4. We have here 24 over 1000. It's because it is powered on 3 because 1000, because it is substituted to the power of 3. So 1000 minus 10. So same process, 1 minus 24 over 990, which is the subtraction or the subtracted result of 1000 minus 10. So same, we have here R minus the result coming from the divided 24 over 990. We have here 0.024. So as a result, we have here 1 minus 0.024. We have here 0.976. So 0.976, or we round up, we have here R is equal to 0.98, a very high reliability. Alright, just take note that the typical retest reliability coefficient for standardized achievement and aptitude test are between 0.80 and 0.90 when the interval is between 3 to 6 months. So as a form part of our result, we have here the 0.98, right? So it is a very high reliability. Alright, next we have letter B, the equivalence. So a measurement of 2 or more tests consistently. So in this method, we have here the 2 different versions of an assessment tool, so administered to the same group of individuals. So 2 or more forms of a test covering the same content whose item difficulty levels are similar. So are you familiar with the parallel form of reliability? So if not so, then pay attention. So in parallel form reliability, it is 1:1 variable but different in presentation. For example, so you want to find the reliability for a test of mathematics comprehension. So you create a set of 100 questions or questionnaires into 2 sets of 50. We have the set A and set B. So di bali, you from the 100 questions that you've made, you are going to divide it into 2 sets. A set of 50-50 from set A to set B, 50 for set A and 50 for set B. So, and then administer those questions to the same group of students a week apart. So, a week apart, take note of the process how we administer the test. That is because of the parallel form of reliability process. So we have here a step-by-step process. So step 1, give the test A for a number of 50 items to a group of students on Monday. So first take na siya, first set na siya. Next, step 2, give the test B to the same group of students on Friday. So as you can see, there is a week interval on the process of administering the test. So that is in the process, that is form part of the process of equivalence, which falls under the parallel form of reliability. So these are the types of reliability that we tend to explain. So we have here the third step. We have here then after administering those tests from test A on Monday, and then the test B by Friday. So after that, then you are going to correlate the scores from test A and test B. So you are just going to compare. You are going to compare the scores of test A and test B, and that is the process of the equivalence. So parallel form can observe and memorize answers within the test, retest. Parallel form can observe and memorize answers. Unlike sa test, retest, reliability, di ba? So ang parallel form kasi, it is a set of questions divided into two from set A to set B, but there is their level of difficulty. So there is also this different levels of questions also. The most challenging part of the parallel form of reliability is the levels of difficulty. So we cannot ensure if it is too hard, if it is difficult. So if it is too hard, it can be complex for our examinees. If it is too easy, so it can either be complacent for all of them. So that is why in a parallel form of reliability, it is most challenging. It is challenging based on the levels of difficulty, and of course in making the test, it is also a challenge to all of them. So to put it simply, in the parallel form of reliability, we are going to find the equivalence. We are going to compare the equivalence between test A and test B. So you are just going to find out if test A measures the same as test B. So in other words, you want to know the test scores if it stays the same when you use different instrument. Actually kasi, di ba, sa parallel form of reliability, from test A, that is the set of 50 questionnaires. And the next set B, we also give 50 questionnaires, but aren't the same of the questions of the test A that we tend to exceed or we tend to administer. So but the same group of students. So to put it simply, we are going to find we are just going to compare the results of test A and test B. That is in the process of equivalence. Alright, we have here letter C, internal consistency. Measurement of tests from randomly divided halves. So, di bali, measurement of tests from the random divided halves. So, what does it suggest? We have here the term, the split half reliability. Are you familiar with that? So, if not, so it is the most commonly used form part of reliability measurement and statistics. And it is the most advantageous and cheaper. So unlike sa parallel, mas costly kayo siya and then mas taxing. It's because the levels of the difficulty of the test and of course the number of the test. So this time, it is the most cheaper daw. So based on the statistics, it is the most cheaper and advantageous types of a reliability measurement, the split half. So parallel forms and split half reliability are similar. But with parallel forms, so the same students take test A and test B with a week interval. But with split half reliability, one group of students is divided or split into two, and both groups sit the same at a period of time. So kabalo na kay tano, it is obvious nga ang kalainan sa parallel, gitunga sila dayon the set A will take the test, then the next the test B will will have this week interval before taking the second test, but the same group of students. But with split half, within that day, gitunga sila and then they're going to set. where they are going to set and take the test. So that is the process of split half. So split half can be used using the internal consistency. To find the internal consistency, we can use the split half method using the Spearman's-Brown formula. So as displayed in the screen, we have here the whole test reliability is equal to 2 times the reliability of the other half of the test over 1 plus the reliability of the other half of the test also. So take note that the Spearman's-Brown formula is used to predict reliability of a test after changing the length of the test. So the Spearman's-Brown formula is used for the reliability measurement reliability measurement of the test after nga naigi dungag sa items or naigi change sa items sa test. So let's say for an example, suppose a teacher uses a 15-item test to assess the student's course. So the test is known to have a reliability of 0.74. So if the teacher increases the length of the test to 30 items, so what is the predicted reliability? So using the Spearman's-Brown formula, so we have here the whole test reliability is equal to 2 times the reliability of the other half of the test. We have the 0.74 or 0.74. Next, we have here over 1 plus, of course, the reliability of the test of the other half of the test, 0.74 gihapon. So we are just going to calculate it. So 2 times 0.74, which is equals to 1.48, and 1 plus 0.74 is equal to 1.74. So we're just going to divide it 1.48 over 1.74, which then we can achieve the predicted reliability of 0.85. So diba sa atong take note ganiha nga most typical nga mga reliability measurement test falls between 0.88 or 0.80 to 0.9, right? So that is the predicted reliability based on the formula used in the process of calculating the internal consistency of the split half reliability. So remember that there are other ways also to establish internal consistency. So based sa book, we have here the Cronbach alpha and the Coder-Richardson formula. So sa ang Cronbach alpha, mo ni siya ang pinaka-popular jud siya nga ginagamit, ang kaning Cronbach alpha, and widely used. So it is used for non-dichotomous items test or who use Likert scales. Diba katong na yung mga Likert scales, mo ni siya ang ginagamit Cronbach alpha. So on the other hand, we have here the Coder-Richardson, or commonly known as the used for dichotomous questions, such as the question answerable by yes or no, and then questions answerable by agree or disagree. So mo na siya ang ginagamit nga other ways of finding the internal consistency, not just the Spearman's-Brown formula, but the book suggests we can use the Spearman's-Brown formula. Sometimes I think it is more it is more understandable and clear for me, the Spearman's-Brown formula. I don't have encountered yet the Cronbach alpha and the Coder-Richardson. But if we are going to apply the statistical data analysis, we can apply this Cronbach alpha and Richardson for those questions that are non-dichotomous and dichotomous. And now let's proceed to letter D, which is the scorer or rater consistency. So scorer or rater consistency, it is an observation-based measurement. So this time, they are going to measure lang the observation. So people do not necessarily rate similarly, right? So wala dili gito pares-parehas og mga judgments and observations, right? So they may have disagreements as to how responses or materials truly reflect on demonstrate knowledge on the construct of skills being assessed. So more so, certain characteristics of raters contribute to errors like biases, halo effect, mood, the fatigue, and among others. So in the scorer or rater consistency, we tend to measure based on our observations. So that is why there are some characteristics or there are some errors that contribute to this biases, our own biases and prejudices. Diba? Biases refers to the partiality or prejudices or in favor or in against of a student group. Such as for example, we have the teacher playing favorites, 'di ba? May muna na siya mga biases nato sa kinabuhi. It's because that is we tend to measure based on the observation that we see or based on the observation that we used to, right? So di ba muna kasagaran natong mga sometimes it can contribute to the errors of the teachers also. It's because of the observations or misjudgments. Next we have the halo effect that turns to contribute on the uh, contribute to the errors of the observation measurements of such teachers. So halo effect, it is a cognitive bias. So from the word itself, it suggests cognitive bias. So allowing our first impression to color one's judgment of another person's specific traits. Diba, murag kanabitang biases nato sa atong pangutok, right? Kanang nihana, for example, when a teacher finds a student personable or well-behaved, diba? Then we tend to bias or we tend to judge that student that this student is diligent and participative, 'di ba? Kasagaran nato ng mga biases. So that is base observation measurement. So before kanang after that ana after knowing that or him in the class, then we can gauge that dili lang pud siya ni ana nga pagkabata, no? Dili lang pud siya nga diligent. There are some characteristics also that he may display or he or she may display. So that is why halo effect should not be halo effect should not be inclined by the teachers. It's because it can lead to favoritism and prejudices of our students. So to mitigate the rating errors, a wise selection and training of good judges and use of applicable statistical techniques are suggested. So it is therefore suggested that sometimes we tend to rate kasi based on the observations lang, right? So we tend to rate based on what we see and what we saw, right? So that is to mitigate the rating errors. Of course, we should be wise in selecting. Of course, to improve reliability of a standardized test, inter-rater reliability is the degree to which different raters and observers or judges agree in their assessment decisions. So there should be a inter-rater reliability, like the interconnections between with the other colleagues. This maybe can be a wise selection, right? So do not just color one's judgment of another person based on the specific traits that he may display. So as a future educator, we should not abide with this halo effect. Especially it is a cognitive bias. Sometimes halo effect, we are aware of halo effect, but we do not tend to, because we are aware of halo effect, but sometimes we do not know that we display that in our students, right? So we display that act in our students. So we tend to color our judgment on the specific traits of a student. So that should not be inclined to. Yes, then there should be a wise selection. So we should train ourselves as future educators to be observant. So in our observation measurement, be wise in observing. So next we have the letter E. We have decision consistency. It described as a consistent classification decisions. So it is an estimate of how consistent the pass or fail decision in your test, right? So this is seen in situations where teacher decide who will receive a passing or fail mark or considered to possess mastery or not. So in decision consistency, we tend to measure the reliability of our student based on the performance they've showed, and then we should be consistent in our decision, right? Say for example, so considering the K-12 students' level of proficiency grading system in the Philippines, right? So we assess our students based on the level of proficiency, and the Department of Education have this a level of proficiency. For the beginning, we have here 74% below. That is for the label or the skills of the beginning students, which underfalls 74% below. For those students who achieve 74% below, they are considered beginners. And next, we have the developing students. We have here the percentage 75 to 79%. So that is the levels of our developing students based on the criteria that we use or that the Department of Education are using. Next, we have the approaching proficiency, which falls under 80 to 84%. So that is based, of course, on the scale. Next, we have the proficient, which is 85 to 89. So these are the students who are knowledgeable enough. Yes, they can be considered as average students. They can play. They can understand independently. These are the students who are proficient, which falls under 85% to 89. And of course, we have here our advanced students, our intelligent students, or classified students, which falls under the percentage of 90 and above. So these are the students who can perform very well, who can perform excellent. So considering the levels of proficiency in the Department of Education, as we are inclined to as future educators in the secondary level, so we should be consistent in our decision making. We should not be playing favorites, because sometimes it is the root cause of chaos in our system, and of course in our parent or student teachers relationship. So as a future educator, we should not playing favorites. We should be consistent in our decisions, especially in the grading system. Alright, moving on, we have here the measurement errors. So measurement errors, it is in observed value variables. So remember that there are two types of measurement error. We have here the random errors and the systematic errors. So random error, it is defined as, it is called noise. So produce random fluctuations in measurement scores. So these errors associated with situations like outside racket during the conduct of the test, subjective scoring, poor instructions, ambiguous questions, and guessing. So random errors does not alter the average performance of the group, but it affects the variability around the average. So we have here in the measurement errors, we tend to measure the error. That is the very essence of measurement errors. So that is why we have here the terminology, the standard error measurement, or SIM. So it is an index of the expected variation of the observed scores due to measurement error. And of course, the standard error measurement have this formula. So standard error measurement is equal to the standard deviation of the square root of 1 minus the reliability coefficient of the test. So where S of X, right, in the as seen in the formula, it is the standard deviation for the test, while R XX, it is the reliability coefficient for the test. So standard error measurement, it estimates how a student's test scores tend to be distributed around his or her through score had the students had been tested repeatedly using the same instrument. So better reliability means a lower SIM, or standard error measurement. So kung mas mas less ang error measurement niya, mas gamay ang error measurement, of course, mas reliable ang test, mas reliable ang scores, right? Diba? So from the test scores of the set of students, so the mean, the standard deviation, and the test scores reliability are obtained. So we have here our terminologies, the statistic terminologies, the mean, the standard deviation, and the test scores coefficient are obtained. So a student's true score may then be estimated by relating the standard error measurement to the normal curve, and then the observed score can be regarded as the mean. So later on, we will going to explain it one by one, all of this statistical terminologies, which is the mean, the standard error deviation, and test score or the reliability coefficient that would be used in the process of inculcating this standard error measurement formula, which is x of x over the square root of 1 minus the reliability coefficient. Alright, let's say for an example. Suppose an individual takes a certain test 10 times over the course of a week that aims to measure the overall intelligence on a scale of 0 to 100. So they receive the following scores of 88, 90, 91, 94, 90, 86, 88, 84, 90, 90, and 94. So if the test is known to have the reliability coefficient of 0.88, then what is the calculated error measurement? Alright, using the formula, we are going to derive the sample mean first. So what is the formula in finding the mean? Of course, x bar is equal to summation of xi over n. That is the formula of sample mean. So from the following test scores that we have, the summation of our following test scores, we have 88 plus 90 plus 91 plus 94 plus 86 plus 88 plus 84 plus 90 plus 90 plus 94 over 10. So the sample mean could resulted to 89.5. So kamo na lang mag-solve dara sa inyong tagsa-tagsa ka calculator. So and that results a sample mean of 89.5. So in the summation of the 10 following test scores. So that is the derived answer, the sample mean. So next we are going to find the standard deviation. So just look at the table below or the solution below. We have here our own table of the standard deviation. We have, in finding the standard deviation, you are going to subtract the following test scores by the sample mean that we get. So we have here 88 minus 89.5, and next we have 88 minus 89.5, that could be resulted to negative 1.5. So in standard deviation, of course, it is the square. We should square it to find the standard deviation. We should square it. So of course, negative 1.5 times negative 1.5 is equal to 2.25. So that is our standard deviation. So same process in the next test scores. We had 90 minus 89.5 is equal to 0.5. Then I squared that to which is equal to 0.25. Same with the third process. We have 91 minus 89.5 is equal to 1.5. Then square na to, we have here 2.25 and so on. So kamo na lang magkuan lang to dara sa scores nga how we subtracted and squared it. So that is the process in the standard deviation. The total of the standard deviation resulted to 90.5. So i-add na lang ng naa sa table. We have here the 2.25, 0.25, 2.25 and so on. To the last term we have 20.25. So i-add na sila tanan, that could be resulted to 90.5. So using the standard deviation formula, so kabalo naman taon sa standard deviation formula, di ba, right? So SD is equal to square root of summation of x minus the average mean squared over n minus 1. So that is the formula of standard deviation. So in total, the summation of our standard deviation, we have here 90.5 over 10, which is the number of turns, minus 1. So the square root of 90.5 over 9 na lang siya. It's because na minusan naman nato ang 10 minus 1. So square root of 90.5 over 9, that is, the result is square root of 10.5. So to find the standard deviation, is square root sa nato ang 10.05. The standard deviation resulted 3.17, and that is our standard deviation. Now that we have find the mean and we have realized, or we have the answer of standard deviation 3.17, so this time we are going to substitute the formula. So, standard error measurement, let's go back to the formula. So standard error measurement is equal to the standard deviation of the scores over 1 minus the reliability coefficient. Kanang reliability coefficient given naman sa atong example, we have here 0.88 atong reliability coefficient. So to proceed, we have here our standard deviation resulted 3.17, then square root of 1 minus 0.88. So next, just follow the flowing process. We have 3.17. So 1 minus 0.88 resulted to 0.12. So that is our answer for 1 minus 0.088. So this time, standard error measurement is equal to 3.17 times unsa may square root sa nato daan ang 0.12 before multiplying it by 3.17. So the square root of 0.12 is 0.346. That is the square root of 0.12. So this time we are going to multiply to find the standard error measurement. We have here 3.17 times 0.346. Our standard error measurement is 1.098. and that is our standard error measurement. So after getting the standard error measurement, so we're going to get the true scores. So diba gisgutan na nato ganiha that after the finding the standard error measurement, then we tend to also to get the true scores of the following students who got that score, specific score. So in order to find the true scores, SEM is subtracted and added to it to get a range called confidence interval. So we should get the range first, and the range that is subtracted and added to it is what we so call the confidence interval. And confidence interval have its own percentage scales. So in confidence interval, in finding the confidence interval, we can also find the true scores kung aha siya nabutang. So the score band have this formula: x plus minus SEM gives a reasonable limit for estimating the score. So ganiha we have here the confidence interval percentage. We have here 68% of confidence interval, which is equal to score plus and minus x SEM. So kung 68% confidence interval ang gamiton, then you can use this formula. Next, we have the 95% confidence interval, which is equal to score plus x 2 times SEM. So that is the formula. So take note that 95% confidence interval, it is the most frequent applied in statistical analysis rather. So in problem solving, 95% confidence interval is used. We also have 99% confidence interval, which is highly excellent na. So which have the formula of score plus and minus x3 as SEM. So what does it mean, the plus and minus 2 SEM mean? So kung siyempre sabot aning kaning there is a part, the ending part. So since you have the standard error measurement calculated already, so 2 SEM would be 2 times the standard. So and the plus and minus means you're asking to calculate the range above, add 2 times the standard error, and of course the range below, add 2 times the standard error. So that is the implications of the plus and minus 2 SEM. So let's say for an example, suppose an individual scores 92 on a certain test that is known to have a standard error measurement of 2.5. So what is the 95% confidence interval? Of course, using the formula, so we tend to use 95% confidence interval. So using the formula, we have here score plus and minus x2 times SEM. So 92 minus 2 times 2.5. So the 2.5 is the confidence interval. The standard error measurement. So 92 minus 2.5. So first operation use. Also we have 92 plus 2 times 2.5. Next, the second operation used, which is addition. So in realizing this formula, of course, MDAS, we should multiply first. So 2 times 2.5 also. So 92 minus 4.5 as a result of 2 times 2.5. Diba kung i-times na to, 4.5 ang result. So, minus first operation use. Next, we have 92 plus 4.5. So, this time, in order to find the confidence interval or the range of the following test scores, so you are just going to subtract and add. So, 92 minus 4.5, 87.5 ang result. And of course, 92 plus 4.5, 96.5 ang result. So, using the round up rules we have here, 87.5 can be round up to 87. 87.5. So sa ato mga interval, we should also limit the below and the above. So kaning 87.5 mo man siya pinakaubos, dili na nato siya ikuan siya 88 kay medyo taas na may laing intervals also ana. So 87, let us suppose 87 yun na siya. And of course, we have here 96.5. Kanina atong pwede i-round up. We have here 97. So, 95% confidence interval. So, this means nga, ang 95% confidence interval, which is equal to the range of 87 and 97. So this means that we are 95% confident that the individual true scores on this test is between 87 and 97. And that's how we get the confidence interval. So next we have the systematic error. So systematic error is referred to as biases. So they tend to shift old measurements in a systematic way, consequently displacing the mean, di ba? So while random errors can be reduced by getting the average multiple measurements, and systematic error can be reduced by identifying and measuring or removing rather the errors at the source. So, di ba, in a systematic error, it is in a form of biases. So, in order to avoid systematic error, so we should identify and remove the errors at the source. It's because the error itself is at the source, right? Diba? So we should remove, especially our biases. We should not be biased in our grading system, right? Especially as educators in the near future, we should be consistent enough in our rating system, especially in the grading system of our students. We should not display biases or any form of favoritism, because as a future, it is a form part of systematic error if we are inclined to that, right? So that is the very essence of reliability. So let us all remember that the reliability indicates the extent to which scores are free from measurement errors. So that is the very essence of our reliability, that we are tend to free from measurement errors. So napakahalaga, importante kayo ang consistency sa mga tests. It's because consistency reflects reliability, 'di ba? Parang sa buhay lang, 'di ba? Hindi tayo dumidepende sa mga taong unpredictable, 'di ba? Hindi natin na predict. So are you willing to give your trust to the person who are unpredictable, yung hindi sure sa mga answer nila, yung hindi sure sa feelings, 'di ba? Paiba-ibang sagot, right? 'Di ba? Are you willing to give your trust to that person? Of course, no. So, same with the reliability test. So, we should be reliable and valid. It is important to be reliable and valid. Yung mapagkakatiwalaan, 'di ba? So, in life, validity and reliability, we apply it at most of the time.